Thank you for coming. Happy Tuesday. So our plan is mostly to work on Lab 5 today. We've got a few things to talk about at the beginning and at the end, but the bulk of the time will be for Lab 5. I've got an announcement, which I'll post to Canvas maybe tomorrow morning, just to remind you. There's a talk put on by the Math and Computer Science department. He's a mathematical linguist where he talks about it it's all about like studying linguistic structures and putting them in like this formal language. And because we know how languages work, there are laws that determine that, and so we can maybe mathematically define that. So I don't know a whole lot about this topic, but it sounds really interesting to me. So if it sounds interesting to you, it's happening tomorrow at 1:30 in Galileo 201, which is, if you go upstairs, it's the big lecture hall. And so I'll send this out in a Canvas announcement probably tomorrow morning. So yeah, that's tomorrow. All right, I want to take a few minutes to introduce you to the project, which is now posted. So if we go to the Canvas page and we go all the way down to the bottom, there's a new module here, the project. And so I'm just going to give you a quick orientation to what that's about. So we've got the main assignment and then some of these indented assignments. These are like sub assignments to help you keep track of your progress and submit like intermittent things to me. So, but all the main descriptions are just in that top level assignment of project. Okay, so I've had this problem in this class for the past several years, and I think it's a really good problem. This is the first time that I've moved it to the end of the semester, and so hopefully that makes it more fun. Previously, I had it in the beginning, which is hard because you're just trying to learn Java and not really knowing what's going on. So hopefully having it near the end is more fun because you can do more things. So it's almost time for finals week, and who here has watched Brooklyn Nine-Nine?
Right.
A few. Okay, so if you haven't watched Brooklyn Nine-Nine, it's one of like the Mike Schur comedies, like The Office or Parks and Rec or The Good Place, where it's basically the like a workplace comedy, and the workplace is a police station where all these detectives are solving crimes and getting into hijinks with each other. And one of the things they do is every year they have a heist, typically like a Halloween heist, where there's something that they need to go find or steal, and they're all working against each other to make sure that it doesn't happen. So I have a link here if you're unfamiliar with it. I also recommend you go and watch the show. It's very funny. But the idea is we want to make a heist. And so this is, if you remember the command line homework, where one of the options was to like have this choose your own adventure game. That's basically what this is like, except bigger. And I have like a theme for you. So it's command line oriented, so don't need to worry about visuals or anything, just printing things to the console and getting input from the console. So the group size is limited to 3. You can work on it by yourself if you want to. I don't necessarily recommend that. It's much easier with more than one person. But if you wish to work by yourself, you can. But the group size is limited to 3 people. So keep that in mind. So your first job is to come up with a situation. So I've given you an example where it's Brooklyn Nine-Nine, but you can choose your favorite piece of media or make something up and come up with a story. So it's also creative where you're writing this story of this is what's going to happen. And there's going to be a deliverable for a script. So this is what I would like to have happen. This is where the user input is going to be. And so that's one of the things. We'll talk about that in a second. But first step is to come up with your idea. The second step is to create classes to manage this behavior. So once you decide on the script, which is here's what the story is, here's what the interactions look like before you start writing code at all, then you get to decide, here's how I want to actually manage this behavior. So you design this sort of hierarchy to say maybe you've got a player and an antagonist, and you've got so there's two sides. There's the object-oriented side and there's the scripting side. So the scripting side is like using the scanner and printing things and making sure the game actually runs. And then we also want to have the object-oriented side, which maybe I have an example which I can show you in another class, which had like, so my situation was the cast of Brooklyn Nine-Nine wanted to go, they're in seminars all day and they wanted to steal the instructor's clickers. And so I had classes for like, this is a team and here's how many clickers they had, which like using classes and object-oriented is a natural way to kind of store that data. So you do need that object-oriented flavor here. So you need to make sure that user input is included, and where you need to, you can have like flip a coin to decide whether or not this thing succeeds. So that's step 2. Step 3 is test and debug. Step 4 is write a README. And step 5 is have a UML diagram, because you've written all this code. And so I want to see what are the fields and methods, how do they link together? In terms of specifications, your project has to use inheritance. So it has to have at least 2 levels of classes. So like 1 subclass and 1 superclass. This is a really small requirement, which you'll see when we look at the lab where there's multiple levels. So you have to at least have 2 levels of classes. You have to have modular code, which is each thing has to be doing a specific thing and not just have it all in one file. That's not good coding practices, especially if we're using object-oriented. And so I have a requirement of you have to have at least 5 classes and they have to be used. So I've got examples there. You have to get the input from the command lines because it's a game, so the user has to play it. You have to have appropriate error handling. So if the user mistypes something, then you ask again. So I'll let you sit with this for a bit. I will note that I've seen what it looks like when AI writes this assignment, and it's extremely obvious to me. So maybe don't do it and come up with your own version. And
What do you mean, maybe?
maybe as in, please don't. I've seen what it looks like when AI writes this assignment. Start early because you are going to run into errors. And similarly, test and debug as soon as you can. So the goal for coming up with projects like this, specifically coding projects, is come up with this minimal working example. So like, even if you haven't done all these functions X, Y, and Z that you need to do, have something that works at the bare minimum, and then add those things on until the project looks how you want it to look. In terms of deliverables, by this Friday, I need your group decision. So maybe during the lab time, you can chat with your friends. I'm not going to do random groups for this. So decide who you want to work with, and you can put them in Canvas, or you can tell me who your group is and I will put them in Canvas. By next Friday, so not this Friday, but next Friday, I want your script. So what's the situation that you're doing? What's your program going to look like? Without having written any code. I'll ask for a progress report, just a paragraph, the following Friday. The Friday before the last week of classes, I'm going to ask for the minimal working example, which I will grade on the scale that I'm going to grade the final version on, just with much less points. So you'll know kind of where you stand on that. And then the Friday of the last week of classes is when everything's due. I may also add a presentation in the last week of classes because this project tends to get like really creative. And so I think it would be fun for you guys to get up and demonstrate, here's what we did. Yeah. Any questions on this so far? Any immediate questions or clarifications? Okay, so your first step this week is to decide if you're going to work in a group, and if you are, who's going to be in that group. Okay, that's the project. Let me know if you've got questions.
We start deciding the groups now.
Maybe not right now. Once we have, so we're going to work on Lab 5, and then I may have time at the end for you to, if you want to talk with your neighbors. I also just want to briefly tell you, here's my plan. So we still have a lot that we need to cover in order for like you guys to be on pace with the other students who have taken this class. And so we need to kind of go rather quickly through the other topics. So I'm telling you this to prepare yourself. We're going to go through difficult topics. So I need you to be here in class and paying attention. The good thing is that I have a lot of activities for this. So I'm hoping to like alternate days. So like Thursday, we'll talk about linked lists and then we'll do the lab on Tuesday. That's the goal. I know I said we would do recursion, but I've looked again at my notes and I realized that's not what I need to do. So we're going to do linked lists and then stacks and queues in class. So that means that I was talking about like we have another subunit for object oriented. We're going to skip that for now because it's interesting, but it's not strictly necessary. And we need to talk about other things. We will use generosity in the linked list, I'll tell you though. Yeah. Just remember that the final exam is on Tuesday at 3:30, the Tuesday of final exam week. So check your flights, make sure you haven't scheduled anything for it. And then one of the last week of class days is probably going to be presentations. All right, any issues or concerns with this or questions? All right. So just to review, last time we talked about abstract classes and interfaces, right? Where abstract classes are these kind of placeholder classes where we say, I don't want to make, let's go back over here. I don't want to make an actual shape class. I just want to make it a placeholder for all the other kind of shapes that I'm going to make. And so when we make an abstract class, we can have abstract methods, which is just, again, placeholder methods to say, we're never going to make an area function. We're not going to define it in shape. We're going to leave it to the subclasses to implement for us. So that's that. We talked about interfaces, which is kind of solving this multiple inheritance problem, where if we want to say like a circle has attributes from two places, so both shape attributes and stretchable attributes, we can do that with interfaces. And so We do that because an interface is a method contract. And so it's usually very simple, where we had the stretchable interface that just says every class that is stretchable, every shape that's stretchable is going to implement this stretch method. And so we're going to say, we're just going to make it abstract and leave it to the other classes to implement. Let me show you what it looks like. Do I have a circle here yet? I don't think I do. Oh, I do. So here we didn't override it. Let's just fill in the shape class really quick. So we pass on the stretch method to the actual class that implements it, which in this case is the circle. And so let's say we just multiply that by whatever factor it is. So that's how we use the interface, where we override it in the class where we want to define it. Okay, I'm going to go back to the slides. Okay, an interface is not a class. The way that we use an interface is with the implements keyword. An interface is not a class. It's just typically a list of method signatures. So the return type, the name of the method, and any parameters that it needs. We define it in the class signature with implements. And then any class, so if class A implements C, the interface C, then A has to implement all of those interface methods or be abstract itself, right? So those same rules apply for abstract methods. Either this class implements it or it leaves it for the next class. You can use multiple interfaces if you want to, just separate them by commas. And then the same rule of you just have to implement all of them, all of the methods. So this, when we talked about the shapes where a circle is a shape, square is a rectangle, this relationship that is a relationship also holds for interfaces. So like a rectangle is stretchable, a circle is stretchable. If you have like a beverage type hierarchy, you can maybe say that like LaCroix is carbonated, but maybe coffee is not carbonated. And if you need to, you can use instance of to see if something has an interface, is using that interface. Same caveats. So we showed an example where like you can't reduce the visibility of something, you can only increase the visibility. That still applies here. You can't use two interfaces if they have the same signature and return type. That's just a conflict. It won't know which one to choose. And so you have to make sure that those things are compatible. If you need to, interfaces can extend other interfaces. And we'll see in lab 5, the interfaces are inherited when the class using the interface gets extended. So we'll see that when we talk about lab 5 in a moment. I also want to mention that there's been this kind of fundamental inheritance that we've had this whole time, where whenever we go to make a new class, so I'll just show you this. If I don't type anything and I don't say this class extends something else, it shows up that the superclass is java.lang.object. So object exists as a common superclass for everything else. And so, yeah, Yeah, so like that's where we start. And so if we go in Google, and so this is the Oracle documentation. This is where we know, this is where Oracle was like, this is how Java works. It's the root of the class hierarchy. Every class has object as a superclass, and then all objects implement the methods of this class. And so we can scroll through and see, oh, there's a constructor. That's what that looks like. And then there are methods that each object has. So like clone, it's got equals, it's got get class and hash code. We've seen those in use before. It's got toString. So that's why when we have toString, it's always an override, where if we look at its implementation, it says that it gives us the class and the name of the class with something about the hash code to a hex string. So that's where the thing that we print comes from, right? So if you're interested, I encourage you to read through this and kind of see what else is there. But just to let you know that this has been the super class all along. Okay, I want to focus on lab 5. So this lab is really good. So let's talk about it for a moment. So over here in lab 5 employee, got a link to the lab, and let's just talk you through it. So can I make this go away? I don't know. Let's open up just the README. There we go. Okay, so this is the lab for you to practice inheritance. So first off, clone it. And I'm going to put you in partners. So try and name it like your name, last initial, your partner's name, last initial. So some starter code has been provided for you, but the files are all completely empty. So it's your job to fill it in. And how are you going to fill it in? I'm giving you a UML diagram. So this is practice like lab 4 with the library where you just fill it in. So step 2 is to look at this diagram and ask yourselves what's there, what do you have, what do you not have, what do you need to create, what fields and methods do you need to add, and how does this hierarchy show up? Which classes need to extend other classes? So let's stare at this for a moment. So I would recommend starting with the interface to create the interface, just so we have that to start with, and then working our way down the hierarchy. So we've got an employee class that has these fields and these methods. In the UML diagram, anything that's in italics, anything that is italicized, those are abstract methods. Italics are abstract. So that tells you what the abstract methods here in employee are. Also do supplier. Supplier is easy once you have the interface. And then keep working on down line. So remember when there's an arrow from one class to another class, so hourly employee to employee, that means the hourly employee extends employee. And so these are all the methods that you need to define for hourly employee. And then down there, we've got staff. So there are 2 types of hourly employees. There's staff members and temporary workers. And then there's also a salary employee that is a kind of employee. Okay, so that's the hierarchy. So I've given you some of this code, other things you need to create, but you need to fill in it all. So I have links for inheritance, interfaces, abstract classes. This link, the gross pay, net pay, and taxes, that's going to be really important for when you implement those methods for what that means. So, and I've kind of broken it down by the different classes. So for the employee, just in general, their net pay is the gross pay. So like if you get a job, you are paid a certain amount and then you have to take like income taxes out of that. And so you've got a gross pay, which is that amount without taxes, and then your net pay, which is the gross pay minus the taxes. And then every employee has an ID, first name and last name, and then just their name. So, which is the two of them smushed together. And they've got a job title. For a salaried employee gets a weekly salary and their taxes are, they get taxed 20% each pay period. So whatever their weekly gross pay is, you take 20% of that and that's their taxes. Salaried employee is your typical gross pay minus taxes, but salaried employees also get $100 benefit allowance. So after taxes are taken out, they get an extra $100. And this is something that people always get tripped up on, where we're talking about weekly salary. And so the information that you have for salaried is what's their annual salary. So you have to figure out how to transfer that from annual to weekly.
Doesn't think you paid every week, or you want us to calculate the total they get paid in a year by adding up all the weeks.
No, I want to know how much do they get paid in a week? If I know how much their total salary is per year. Okay, so for hourly employees, all hourly workers have a pay rate and the number of hours worked. So this makes sense if like you've got a campus job where if you're getting paid $15 an hour and you work for 5 hours, then you just multiply those two numbers together and that's how much you get. Doesn't make sense. It doesn't make sense to say, here's how much taxes, because we'll specify that for staff and temporary. So it gets more specific. So for staff workers, they get taxed 15% each pay period. For hourly, the temporary employees, those are like temps, they're employed through an external agency, and we assume that agency covers the taxes. Suppliers don't work for the company, so they're not employees, but they do need to be paid their amount due. So we need to keep track of that. Okay, so that's the instructions. So implement all of those, then run the payroll tests. You can run it as you go, but it'll be errors for the things that you haven't done yet. So just like click OK and keep going. Yeah. Any questions before we get started? Okay. So I'm going to pause recording, put you in your groups, and I'm going to give you maybe 45 minutes to work on it. We'll come back at 4:45 and do an activity, and you can finish the rest of it outside of class with your partner. So make sure you share contact information. Okay, so we've got some questions left on the packet. Let me see. So we've got 10, 11, 12, 13, maybe 14 or 15. So I just want for us to review. So now that we've had some practice working with abstract classes and interfaces and stuff. So first, like put a pause on lab 5. You can finish it outside of class and start with problem 10 and ask, is, did we, I don't think we talked about this one. No, great. So yeah, so answer each of these in your group. Is it true, false, or it depends? So talk about it. Go for it. Have maybe 3-4 minutes. Okay, what do we think? Does an abstract method have some code in it? Here, yes. Does everybody think yes?
Yes.
Does an abstract method have any implementation?
Yes. It's classes.
Yeah, but when we define the public abstract something, do we need any code? No. And the second is related to it. Does an abstract method need curly brackets? No, because there's no code. All right, so this one is asking, like, what do we call something that's not an abstract class? Do we call it a non-abstract class? Or do we call it something different? Yeah, you're right. This one is worded confusingly, and I wasn't sure how to structure it, but this is true, and this is telling us that that way we either have an abstract class or a non-abstract class. They're complete opposites. So either it's abstract or it's not. All right, so you can make an object out of a class if that class only has one abstract method. There's only one abstract method, we can make an object out of it. True or false? Okay, thumbs up, true, thumbs down, false, thumbs to the side, not sure. One thumbs down, one thumbs to the side, two thumbs to the side. Thumbs down. Yeah, so this is false. So if a class has at least one abstract method, the class itself must be abstract. And we cannot construct an object from an abstract class. So this one is false. All right, what about this one? If B extends A, so A is the superclass, B is the subclass. A has an abstract method M. B does not have to implement M.
But it has to,
Does it have to?
think so.
So, any other ideas? So the answer here is it depends. Because either, so you see this in the lab with employee, where like in employee, get net pay, or wait, no, get taxes. Let's take get taxes. That's an abstract method. And so hourly employee does not implement get taxes. Because so it doesn't have to, even though it extends employee. But what we can do, so since it doesn't extend get taxes, hourly employee has to be abstract itself. And it kicks the can down the road to say staff and temporary, you are going to decide what taxes mean for you. So the answer is it depends. So if B is non-abstract, Then we need to implement M. But if we don't want to, B can be abstract. So it depends. All right, and then the last question here, the word used to make something abstract is abstractify. Is this correct? We type abstractify in Java, will it work? No. The word is actually abstract. Okay, so here's what I'm gonna do. So I would like you to go through the rest of this packet, except for maybe problem 15. So maybe you can skip 15 or actually no, I would like to do 15, but what you can do is you can meet up with a friend from class and do the activity. So this is part of homework. And so it's just we don't have time to get to it in class. So I'm assigning it for out of class, where you either you do this by yourself or you meet up with a few people, friends from class, and you come up with some examples. So give me some abstract, give me a hierarchy. Some of the classes are abstract, some are interfaces, and draw this. And so you can draw that in the space for question 15. So the rest of the packet is going to be your homework. I do want to spend some time for you to maybe talk with the people in the class and try and decide your project groups. So, yeah, so for the next 3 minutes or so, maybe talk with people, ask, do you want to be in a project group together? And we'll go with that. So make sure to, yeah, so communicate, make sure to finish lab 5. And that's gonna, I think it's due on Thursday. So talk with your friends and figure out your project group.